Hey everybody! One day I was just mixing some random chemicals in my garage and then all of a sudden, BAM! I found a dead Superman on the floor. And here's how you can do it too. Nah, this story is not entirely true. That wasn't Superman.
What?
Anyways, today we're gonna make some kryptonite, which are those cool-looking bright green crystals. As I understand it, in our world, kryptonite can be referred to as potassium trisoxalatoferrate 3, which is more simply referred to as potassium ferrioxalate, which chemical formula is the following. Here is an overview of the entire process, but don't run away because we'll get to play with fire. Also, it's quite easy to do and all you need are 4 household ingredients. First, you'll need iron. In this case, I use steel wool, which is commonly used for sanding. You'll also need oxalic acid, which is a common rust remover, potassium hydroxide, which is a strong base that's used for making soaps as well as being a fertilizer, and finally hydrochloric acid, which is a strong acid that's perfect for removing limescale from your toilets. First, we'll need to make some iron 3 chloride. For this, one could think that you can just take some iron and add some hydrochloric acid to it and call it good, as the reaction is clearly going on. However, doing so will only make some iron 2 chloride, aka the green stuff, instead of the required iron 3 chloride, aka the orange stuff. Therefore, more oxidation is required. One way to do it could just be to wait, since iron 2 will slowly oxidize in air, as you can see on the sides of the tube where the splashes are becoming more yellow. However, this is a slow process and it will take at least 3 times forever, which is not ideal. So no. No. Instead, we can benefit from one of the properties of steel wool, which is its ability to burn. You see, due to its large surface area and small volume, and the fact that combustion releases energy as heat, the reaction is self-sustained, which means that when heated, steel wool will burn. Quick side note, the temperature here can reach up to 800 degrees Celsius, which is obviously dangerous. Also, performing this experiment on top of a precision scale like this one is a really nice and original way to break it, as mine almost died. So yeah, just don't be stupid. Fun fact, the burned steel wool here is actually heavier than the starting material, since oxygen is combined with iron in the process and stays there as a solid. Also, you can set steel wool on fire by touching it with a battery. Anyways, now that our iron has been oxidized, we can mix it with HCl and watch it slowly transform into iron 3 chloride. For the second step, what we want to do is to create potassium oxalate. All you need to do is to mix potassium hydroxide with oxalic acid in a 2:1 molar ratio, which means 2 molecules of potassium hydroxide for each molecule of oxalic acid. Since this reaction releases a lot of heat, it's highly recommended not to do it all at once, but rather in small successive additions. And now, for the third and final step, all we need to do is to combine our 2 previous products together.
3, 2, 1, go!
And just like that, you get a very nice and green... Okay, what was supposed to be translucent green is now opaque and yellow. However, once you let it settle for a while, you see that you get a green liquid, which is pretty much what we want, but highly contaminated with this yellow stuff. I then decided to add some more potassium hydroxide and oxalic acid, and eventually I made it work. Worse. I made it worse. I then tried numerous other things, including adding HCl, which only turned it red, and then add potassium hydroxide, which only turned it black. This was expected, because HCl only made the iron soluble again, and then adding potassium hydroxide made it precipitate. And then I had an aha moment. I took a sample of those iron particles and stirred them with magnetic stirring. However, when I stopped the stirring, I could see that the particles would aggregate on the magnet. And this definitely shouldn't happen. Also, when comparing the mass of the steel wool both before and after burning it, I could see that the mass difference was not as high as it should be. Also, I saw that when I reacted burnt steel wool with hydrochloric acid, bubbles would start to come out, and those were likely hydrogen. Also, the oxide that I recovered was black, and it should be red. Maybe there's something more. Something we don't know. Something they don't want us to know. Or maybe I'm just dumb. You see, after a bit of research, I found out that burning steel wool in air doesn't give iron 3 oxide as I thought it would, but rather mixed iron oxide, which has less oxygen, therefore less mass, which produces hydrogen when reacted with HCl, which is magnetic, and which is also called the black iron oxide. Who could have possibly known? Anyways, now armed with my newfound knowledge, I decided to recover as much of the fine black iron particles as I could, which was a real pain, as you can see from the looks of my beaker. And then I reacted it with hydrochloric acid, but also hydrogen peroxide, which is a strong oxidizing agent. I then decided to precipitate the iron by adding some more potassium hydroxide, and though you might not be able to tell from the video, this time the precipitate is definitely reddish brown instead of black, which is good.
Wow!
I then washed it a couple times, removed most of the water, and we're now left with a thick fluid that looks like liquid brick. Now, I just made the solution from step 2 again, and then mix the two together. And once the solution clears up, we are granted with some nice neon green liquid. All that's left to do now is put it in a tray and let it dry. And then, after a long and rocky road, we have our green crystals. So, I know some of you are wondering, but how do we know this is real kryptonite? Unfortunately, I've never met the guy, so I couldn't really ask him. Hello, citizen. Oh my god, this is Superman! Hey, is this kryptonite? Okay, I have to go now, so thanks a lot for watching, and I'll see you on the next one. Bye!